Welcome back. We're going to learn a bit about conics. And you watched a video last week that was just kind of a general thing. So there's a cone, and the cone is double-sided. So you think of an ice cream cone and then another one on the bottom. If you cut it straight across, you're going to get a circle. If you cut it at an angle, you're going to get an ellipse. If you cut it parallel to the one side, you actually get a parabola. And if you cut it straight up and down, you get what we call a hyperbola. Now we're going to start with parabolas because you know parabolas, but you don't know how they're formed. Like, you know that they come from an x squared equation, but that's pretty much it. So a parabola, by definition, the set of all points such that they are equidistant from a fixed line, which we call the directrix, and a fixed point, which we call the focus, and the focus cannot be on the line because then it doesn't work. So I have a lot of different lengths of paper cut, and I'm going to show you how we can actually create a parabola so you'll understand what I mean about this equidistant thing. So let me slide this up, and let's draw a straight line. Right, here's our straight line. This will be our directrix. And let's draw a focus. So let me get my shortest piece of paper. About right there. Okay, so this is the focus. Okay, so first thing is I'm going to get, so clearly if I drop an altitude straight down, it would be a certain length. So we want to get a point that is, let me just mark this piece of paper. So half of that, if I fold this, half of that, if I put this right back there, let's see, half of that would be right here. Okay, so that is equidistant because this is distance 1, and this is the same distance, distance 1. They're equal. Okay, so I'm going to take this piece of paper, and you can see that it's too long. But what I'm going to do is I'm going to fold it in half so that I know that the two halves are equidistant. And I'm going to use this to create points. And you're going to see we're going to form a parabola. It's going to be a little bit. So you see that this distance, because I folded it in half, I put a little dot right here, and now I draw this in. This is distance 2, they're equal. And I can actually do that on the other side as well, because clearly there's going to be some symmetry here. We already know that parabolas have symmetry. Okay, we're done with that paper. Let's get on our next piece of paper. I'm going to fold it in half just like the other one. And once again, we're going to get it so that it is, oh, we have to unfold it a little bit more. Hold on. Perfect. Okay. So that point is equidistant from the focus and the directrix. So this point, and I'm not going to keep on writing D1, D2. I think you get the point. This distance and this distance are the same. So you can see it's going to start to make that parabolic curve that we know. Let's see, we're done with that one. Next one. So here's another piece of paper, a little bit longer. I'm going to fold it in half because I want the two sides to be equal. Same thing, let's, perfect. Okay, so we could see it is forming that curve, that parabolic curve that we know about. So that is the definition of a parabola. Now, you've never seen the parabola like this in this form, and that's okay, no big deal. This is just, everything was formed a certain way in mathematics. This is how parabola was formed. We describe the parabola much easier with like y equals x squared or whatever, something like that. But, you know, it is actually part of that group of shapes known as conics. All right, I swear I'm almost done. I've got 2 more pieces of paper. And now you can see, like, it's going to start to go like this. Oh, hold on. Okay, perfect. Another dot. So you're seeing that parabola. One more, last piece of paper. I cut them all out for you guys. We're going to use them all. All right. Okay. Oh, that one was a little bit off. That's okay. But you get the point. You're creating the parabola, and every one of those points I drew was equidistant from the focus to the point, and then from the point to the directrix. Like, let's do this point right here. Right? This we can call D3. This is D3, and that's equal to this. The length of those 2 lines will be equal. That's the definition of a parabola. Okay, fantastic. Let's actually move on to some equations and some other stuff. Okay, so you are used to this formula for a parabola, anything with an x squared. So ax squared plus bx plus c. But what we're going to do is we're going to write them using the center or the vertex. So if we go back here, this point was the vertex. And then we can use either the focus or the directrix. And what we know is that they are equidistant. So if we have this one, we'll be able to find the other one pretty easily. So anyhow, ax squared plus bx plus c. We're going to be using this, which we're going to call standard form. Is going to be x minus h squared equals 4p y minus k. HK, YK. HK is the center. Not the center, I'm sorry. Is the vertex. And then this p value, this has to do with the directrix. So the directrix is y equals k minus p. Because k is the y value of the vertex, so it's saying p units below the vertex will be the directrix. And if we wanted to find the focus, we'd do k plus p. We'd add the p value, because that p value, if you go up or down, but no big deal. And this is for a parabola opening upward like that. Now, if we wanted to do a sideways parabola, all we would do is switch these values. We would do y minus k squared equals 4p x minus h, where hk is still the vertex. The directrix now, because it's a sideways parabola, the directrix is this time a vertical line, and then the focus would be in there. So it's going to be x equals h minus p. All right, so we're going to take this information, and we're going to use that to find the standard form of a parabola. So we're used to doing this in another form. So we have a parabola with a vertex at 2, 1, and a focus at 2, 4. Okay, so we can actually sketch this out a little bit. That might help us because I think you need to at least know what type of parabola we're dealing with. So let's just, okay. So vertex at 2, 1, focus at 2, 4, which means the directrix, the vertex should be directly between. So if this is 3 units up, we're going to go 3 units down, and we're going to put our directrix, which is going to be right here. So a parabola is going somewhere like that. Okay? All right, so we're going to start with x minus h squared equals 4p y minus k. Well, let's start to plug in the values we know. So we know hk is the vertex, so hk is equal to 2, 1. That's easy enough. We need to find this p-value. If you remember, the equation of the directrix is y equals k minus p. Well, the directrix is y equals -2, right? Because it's a horizontal line at -2. So let's see. We know the k value is 1, and that'll help us find the p-value. So this should be equal to 1 minus p. Well, what is p? 1 minus 3 would give us -2, so p equals 3. And there we have it. So now we have enough information here to put this all together. So, let's see here. Let me just slide this up. I need just a little bit more room. X minus 2 squared equals 4 times 3. I'm going to make that a 12. And then y minus 1. So even though we were not asked, we could put this into our normal quadratic form if we would like to. Because I know that, like, if you wanted to graph this, obviously this is nothing that you would graph. But we would square this out. So x squared minus 4x plus 4 equals 12y minus 12. I'm actually going to add the 12 over to the other side. So 12 and then plus 4. I'm going to get x squared minus 4x plus 16 equals 12y. And then I'm going to multiply by 1/12 on both sides. And that cancels, and there it is. That's our normal form. So y equals 1/12. And that's just a number. You can multiply it through, you can leave it like that. X squared minus 4x plus 16. And that's something you're a little bit more used to seeing. That's more common for you. So, yeah. You can put them in this form if you prefer that. Okay, so what if we have something like this? Y is equal to -2x squared. I would like to put it in that form that we just had. So in order to do that, I have to, clearly, because the x is being squared, this is a traditional parabola, so I'm looking for this form. X minus h squared equals 4p y minus k. So I'm going to actually move the -2 to that side by dividing it. So I'm going to have -1/2 y equals x squared. And I'm going to put that in parentheses, x minus 0 squared. Because that's showing me, because there's nothing else being added or subtracting, that must be x minus 0 squared. Now, same thing here, since there's nothing plus or minus, that's going to be y minus 0, and I'm going to kind of factor out that -1/2. So, -1/2 y minus 0. And the only other thing to think of is that -1/2 is 4 times p, so what must p be? So it's actually 4 times -1/8. Y minus 0. X minus 0 squared. And then from there you can find all of your different parts of the parabola.